So, greetings, everybody. Welcome to conference day 2, track 1, first presentation. Before we begin, I'd like to acknowledge our sponsors, without whom we would not be having this wonderful conference. We have the Evergreen Collaborative Development Initiative, Midwest Tape, Equinox Open Library Initiative, Stack Courier, and Unique Management. Thank you to all of those. And for this next presentation, I am pleased to introduce Mike Rylander. Mike is the Research and Development Manager at Equinox Open Library Initiative, as well as one of the OGs of Evergreen, as many of you know. And he will be talking about, his presentation is entitled Situation. There are 15 competing standards, and he'll be talking about developing RESTful API. Mike, over to you. You're muted.
Yes, I am trying to figure out where the screen share is, where I get to pick which screen I'm sharing.
Bottom, middle, in between the gear and the smiley face.
I did.
And then it should offer you what to share there. And just as a note, I will be monitoring the chat. And if you want auto captions, there's a closed caption button down at the bottom. Right. Mike, do you prefer to be interrupted for questions or hold questions to the end?
You can interrupt me if we can do it between slides.
Got it.
That'd be good. If it's obviously something important and cool that we should talk about.
Okay. Only important and cool questions are allowed to be interrupted. Got it. Take it away.
Perfect. All right. Well. Thank you, everybody, for joining us. This will not be nearly as fun as the Ruth and Andrea show that I hope you all watched just minutes ago. I do not have a theme, but there are lots of pictures. So we'll see how this goes. And this is a bit of a follow-up to a presentation I gave a couple of years ago. Thank you, Jason. About the first experiment in RESTful API that Galen began and I took the baton on and carried forward. Yeah. All right, so I'm Mike Rylander, Research and Development Manager at Equinox. I know most of you, I'm sure, either virtually or in person. We've met at various conferences and whatnot. And this is, in fact, about the pile of APIs and API-like things that have started tumbling off the table, trying to crush me. That is actually a shot of me being attacked by a box full of APIs that I can no longer control. So some expectations about this presentation. This is aimed at more technical people, Evergreen developers, and system administrators, and ideally third-party integration developers, folks that want to talk to Evergreen but don't want to have to deal with the 20-year-old Evergreen API-ish things. And as Andrea mentioned, or as Andrea asked about before, I want this to be as much of a conversation as we can do. So if you have a question, do feel free to interrupt. Between slides would be better, but you know, if it's important, grab me. There will be links in the slides when they're shared to the documentation for the RESTful API, OpenAPI stuff in Evergreen. There's a lot more information in the documentation than we're going to be able to get through in this 45 minute presentation. We will be going through some terminology. There are a lot of new words that we'll be using when we're talking about RESTful API and OpenAPI as we go forward, so that we in the Evergreen community can start talking to the wider world in terms that they understand, and so that we can kind of provide some mapping between Evergreen concepts and the OpenAPI concepts. We're going to talk about some analogs that already exist. I'll try to go through the glossary stuff relatively quickly, but if there's anything on there in particular that you'd like more information on, happy to stop during that and talk about it to clear anything up. And we will be going through pretty much all of what's listed there in more detail further on in the slides. So if you just want to know about it, you can wait. If you need clarification though, go ahead and raise a hand. And we'll talk about what existed before relatively quickly, and why it's very bad and terrible and we don't like it anymore. Just kidding. But we will also talk about why the RESTful API infrastructure is hopefully a long-term path forward for integrating other stuff with Evergreen. We're going to talk a little bit about the parts of the OpenAPI and RESTful API infrastructure. And then we're going to take a look at some of the technical pieces that are more important to the people that will be doing new integrations, and providing feedback on how we can improve the surface and breadth of the API that we expose through OpenAPI. I did spend a little bit of time last night building a quick new endpoint for OpenAPI access point. It's called an endpoint. Get into that with glossary in a minute, and we'll go through that. And then we're going to squash some bugs, or we're going to see how the bugs were squashed while I was trying to add that, because I needed to fix a couple things that will be going hopefully into the next maintenance release of 3.15. And then we can stop and talk about what we saw, or we can leave early if we've talked about it all during the presentation. All right, so quick glossary. The most important piece from an API perspective, and especially how do we replace existing APIs with something new for Evergreen, is the field mapper IDL. It's an XML file that describes the, among other things, the structure of the database, the shapes of the objects that Evergreen uses, that Evergreen passes around between different components, and everything inside of Evergreen uses the IDL to not have to hard code anything. It's a single repository for how the data is shaped in Evergreen. But it's also something that nobody outside of Evergreen understands how to use, and it is difficult to use if you don't use our library bindings. Now, OpenAPI, that's the general standard. It started as Swagger in 2010. A company called SmartBear bought Swagger, well, took over Swagger, and then donated the spec essentially to the Linux Foundation, who then stood up the OpenAPI initiative, who then created the OpenAPI specification. But it is what everybody out in the wider world has basically agreed to use as the description format for how to share APIs between different web-based services. The most important piece of the OpenAPI specification is the the description of how to create an OpenAPI document. The description document tells the world how your API works, what the endpoints are, what the URLs to get to those endpoints are, what the input and output it looks like, and just generally how to interact with your services. And part of that, part of the OpenAPI description document is a schema, and the schema objects in the OpenAPI description document are a close analog to our field mapper IDL classes. Yes, that's foreshadowing to answer my question in the slide. Now, getting over to the Evergreen side of OpenAPI, what do we need to build in order to, or what do we need to set up in order to make it possible to translate from how we do things on the Evergreen, on the inside of Evergreen with OpenSRF and the field mapper IDL to what OpenAPI consumers expect to be able to see? Well, the first thing is we need to be able to constrain the access to the API. And in order to do that, we've invented a new mode for user accounts to exist in. It's called an integrator. And integrator accounts can have a special password type of API. They have access to, by having an integrator, by being marked as an integrator or promoted to an integrator, they have access to a special login type called API, which is separate from the main login that's used for the OPAC and the staff client. And it uses the separate API type password. And you can think of that as the API secret key for that user. Just like when you sign up for a web service, you have to get a user account and a secret. This is that, but we're building it directly on top of existing Evergreen functionality and concepts, so that you don't have to learn anything new, and developers don't have to worry about the Evergreen developers don't have to worry about a whole separate set of accounts for API access. There's a new thing called permission sets. These allow you to collect a set of permissions together and assign them to various things to say, in order to access that, you need this set of permissions. You can assign as many permission sets as you want, and as long as the integrator or the user, the normal user in some cases, has all of the permissions in one of the sets, then they're allowed to do the thing they're asking to do. Now, this is just a front door permission set, so all of the business logic permissions that are required on the back end on Evergreen still need to be set up for the integrator users in order for them to do the thing they're asking to do. But this is a way to gate which capabilities an integrator has access to. Endpoints are what we call OpenAPI operations. They're slightly different than the definition provided in the OpenAPI specification, but it is a pretty direct mapping. You can think of an endpoint as the combination of a URL and an HTTP verb. So you may be able to say get hold number 1, or you may say patch hold number 1, and patching hold number 1 would let you update the hold, but you're doing it through a RESTful style OpenAPI interface. Endpoint sets allow you to collect a set of endpoints into a group, and that group can be assigned a set of permissions through the permission sets. So you don't have to individually assign permission sets to each endpoint. You can just say all the bib stuff goes into the bib set, and in order to use the bib set, you need these 3 permissions. And rate limiting, we need to be able to, because OpenAPI is going to blow the doors wide open and everybody's going to use it on day 1, we need to be able to constrain the incoming requests a bit. So we have the ability to rate limit. Rate limiting is a number of requests per unit of time, and you can do it per endpoint set, and attach those to restrictions to specific integrator accounts, or to IP ranges that your integration partners may be coming from. So you can have a 1 request per 10 seconds general rate limit, and then if you have a third-party vendor that needs to be able to make 10 requests a second, you can give their IP range or their integrator account a different rate limit so that they can have more access. Now the old stuff. For the Evergreen developers out there, you know most of this. For the system administrators, you certainly know some of it. But this is all the ways that machines can talk to Evergreen today. Well, not all the ways, but many of the ways that are prescribed API type access. We have OpenSRF directly over various transport mechanisms, including, thank you, Bill, for the Rustish, I'm going to call it the Krabby Gateway. I don't know if that's a name that Bill actually wants it to have, but the Rust Gateway now does do field mapper free translation between OpenSRF and the broader web. But we'll see here where OpenAPI may be a more accessible and more broadly useful implementation of that, at least for third-party integrators that are not used to dealing with Evergreen specifically or library data generally. All of these APIs have been around forever. Some of them are standard, especially in the library world, but the library-specific ones like SRW and SRU, SIP2, which is not library-specific but seems to be mostly used in libraries these days, and the others there are very niche. So if we can provide some of that same functionality in a using a protocol that non-library developers know how to use, I think we'll be winning. Now, the new stuff, OpenAPI, and specifically the RESTful interfaces that we built here. I'm not going to read the entire wall of text here, but each of the features has a particular benefit, and the biggest one really is those first 2. It's that part of the startup process of the OpenAPI server for Evergreen is to take the IDL at runtime and turn it into a JSON schema and publish that schema as part of the OpenAPI description document. That means that any conforming OpenAPI client should be able to consume that description document, including the schema, and understand exactly what the data they're going to see should be shaped like, and be able to pass JSON objects that conform to those shapes to Evergreen, and we'll be able to turn them into field mapper objects regardless of the specific Evergreen version. And because it's done at startup time for the OpenAPI server, it's It also does not care if you've made local modifications to your IDL. So you can add tables to your database, put them in your IDL. Maybe you're using that for reporting purposes. Well, now you have access to it through OpenAPI as well, if you want to be able to do that. Now, back in the 2023 version of this talk, I showed where there was a huge blob of code that you had to create for each endpoint, and while it certainly wasn't the hardest thing in the world. Now it's literally just a few inserts into a database table, or use of the API control script, which we'll get to in a minute. And if there's a need to massage the request in some way to, maybe you need to make multiple requests in order to fulfill the OpenAPI requirement. On the outside, a very thin wrapper code that looks extremely similar to the way you would write a method for Evergreen itself. So if you can read Evergreen code, and particularly if you can write an Evergreen or edit an Evergreen OpenSRF method, you should have no problem creating simple wrappers for use in the OpenAPI server as well. So there are two major parts. Let's see. No, I'm sorry. I'm just gonna, between slides, I'm gonna check. No, we're just talking about crabs. Cool.
No, we're all good. I'd have interrupted you.
Perfect. So there are two major components that make up the OpenAPI infrastructure. There's the OpenAPI server daemon. This is what reads all the configuration out of the database, pulls up. I can do that, actually.
I was gonna say, yeah, I don't actually have access to his slides.
There you go.
There you go.
No problem. This is a conversation. The OpenAPI server when it starts up, it reads a bunch of information out of the database that describes the endpoints and the endpoint sets and the permission sets and all of that stuff that it needs to know in order to create the API, OpenAPI description document. And it reads the IDL, as I mentioned, and generates the enormous pile of JSON that is used by OpenAPI client libraries to create, to let them access Evergreen. And there's also an HTML interface to that, so you can take a look at it. It's the built-in one is not the best of them, but it also doesn't explode when you try to browse around the enormous schema that's generated. The Swagger tools on swagger.io, editor.swagger.io, those are not meant for something quite as big as this, it seems like. But your actual development SDKs should not have a problem with any of that. There's the API control script, which keeps you from having to go directly to the database and insert stuff by hand. The documentation describes it's a command line script or a command line tool with a kind of a choose your own adventure menu system that you walk through to configure the various parts. It tries to lead you down the paths that make sense, but I would really, really, really like this to be turned into an interface in the staff client. There's no reason it couldn't be. It just is a much bigger job than writing a command line tool ended up being. So we went this way first, but you can use the API control script to manage your integrators. You can promote regular users to integrators, set their secrets, aka passwords, set blacklisting and whitelisting of IDL fields, do all the things through the API control script. Now we're going to look at a little bit more in a little more detail at some of the things that the OpenAPI server does in the course of processing a request. We talked a little bit, I talked a little bit earlier about the new login type that is built into the OpenILS auth service. It does require that the user attempting to use the API login type be an integrator. So you can create a user that does not have OPAC login or staff client login, but does have the API login permission, and they will be able to log in for they'll be able to get an authentication token for the purpose of APIs specifically, and as long as in the areas that protect themselves based on the OPAC login and staff client login permission or staff login permission, that auth token won't work in those areas. There are a set of new permission groups with a set of new permissions that are different for each, that give you the beginnings of how you might want to lay out your more complicated permission sets. Now, I expect most of the time those permission groups won't be added to or changed too much, at least until there's a much larger and coordinated effort at the broader API surface design. But there's nothing stopping anyone from using those groups or different groups going forward right now to enable third-party integrations, even with the version 0 of the API that we've released in 3.15. One caveat is that the API control script is specifically meant to deal with integrator accounts. It does not let you control any of the regular account stuff. So you're only dealing with accounts that have been promoted to be an integrator. But that's who you want to be handing out API keys to anyway. You want to control that by being able to disable them. You can disable an integrator, and it will immediately stop responding to that user's requests. Authorization. So I mentioned it a little bit before, but just to reiterate, endpoints and endpoint sets can be given permission sets and individual permissions. This is kind of the frontline authorization mechanism for endpoints. That's right, Chris. Thank you. That is the doors of Dern. It's the front door for every request, not just for authentication. Each endpoint, when a request comes in, checks to see what permissions it's gated by, checks the authenticated user's session to see if that user is valid first, and second, that they have at least one full set of permission set permissions or individual permissions. So you can create a new permission, assign it to an endpoint, and then you just have to give integrators that one permission. If you want to have a special sneaky permission that you want to allow specific users to be able to use specific endpoints for. And as I mentioned, but I'll reiterate, this is using the regular Evergreen backend code, so any permissions that are required for actions in the normal Evergreen business logic are still required of the integrator users. So you need to you do need to make sure that you you add those permissions to those integrator promoted accounts. One does not simply, that's right, Chris, knock on the, or one does not simply walk through the API. We log everything that goes on. Yes, Jeff. When you make a request, we log when the request started, we log whether the request succeeded, and then we log the time that it completed at, whether it succeeded or not. And we do that so that you can build metrics and detect any abuse or unexpected traffic. And all of the logging, we do that in the database intentionally so that you can report on it. And I talked about rate limiting a little bit before, but the reason we need the reason we want to do this is that we haven't had an API that other non-library developers have been willing to fully use. We've had APIs, we've had things that look sort of like this, but we haven't had anything that didn't require more complication than people were willing to put up with. So because this is going to make things much easier, we really want to make sure we can limit the request flow by IP or by specific integrator account, or just generally. And there is, by default, there is a rate limit of 1 request per endpoint per second per integrator. So you can increase that. It's easy to do. But basically, you can make a request once a second to each of the endpoints after you've logged in, and you won't pass the threshold. But it does try to be as nice as possible and throws a HTTP 429 and returns a reply or a retry after header with the number of seconds that they need to wait before their rate limiting restriction expires for that specific endpoint. Now, there are fields in the Evergreen database that we don't want to expose. And those fields, for me, might be different, a set of fields from the ones that you don't want to expose. So we have built a mechanism to have global field stripping or redaction, so that regardless of which endpoint a piece of data comes out through, that field on that object will be removed. Likewise, you can whitelist previously blacklisted fields for specific purposes. If you have an integrator that needs to be able to see a piece of data that you generally don't share, you can allow that. And the other way around as well, you can say, I don't want my integrator that's doing general patron notification to get access to their mailing address. So you can block out their mailing address if they're just doing digital notifications or whatever. The whitelisting can be whitelisting and blacklisting can be across the board, can be per endpoint, and it can be per specific integrator as well. And this happens as part of the infrastructure. So as the objects are being rendered to go out the door, that's when we take a look at them and say, all right, what can stay and what needs to go. So we always make sure that before the data leaves the door, the front door, we have removed anything that we have been told we must. And finally, one of the things I noticed about halfway through development of this was that, wow, our objects are big. And also, wow, about half of the fields on the objects are usually null. So we can get rid of all the null fields and ship out a much smaller pile of data with each result. It actually speeds things up a good bit. And it's just less wasteful on bandwidth and other resources. 50% is probably the minimum in aggregate that you will see in reduction. It's not turned on by default, but it may be something we want to consider turning on by default. And just to show what I mean, this is just retrieving a hold slightly fleshed, hold number 181 from the Concerto test data, with all of the nulls still in there, and then the bottom one is without. So you can see it's a little less than half the size when it goes out the door with the filter nulls set to true. Now, here's the fun part. We are going to see how we can add a new endpoint with new functionality that isn't covered in any way in the current API surface as it stands. We're going to find out who we can blame for my hold not getting filled. There's a table in the database called action unfulfilled hold list, and every time we retarget a hold, we write a record that says, hey, the last library was supposed to fill this and they didn't. We record the time that we moved away from them and the copy that was originally targeted at them and which library it was. Well, Chris, we don't record the staff member, unfortunately, so we can't blame an individual person. But we can find which libraries have utterly failed us when we were trying to get the latest book in the series. So we're going to create a new endpoint set. We're going to create a new endpoint. Endpoints have a symbolic name separate from their URL, their verb, and their Perl method name or subname. We're going to pass a hold ID. It's going to respond with an array of objects. It's going to just require the OPAC. I'm glad that was on your list, Andrea.
It's not on my list. I don't like that idea. I'm just saying I think it's already out there.
Oh, it is a wish list, not your particular wish list. Got it. it's going to respond with a list of an array of objects that describe all of the failures up to this point, and it's going to be gated by the OPAC login, an OPAC login permission. So we're going to test it using a regular OPAC user, a regular human.
This is your 10-minute warning, by the way.
But let me go quickly then. Here's a wall of code. Well, code screenshots anyway. So we've got a Perl package with one method in it. Pretty simple method. It checks to make sure that the hold is a number. It goes and gets the hold and makes sure that it belongs to the user asking for this. And then it gets the list of capture failures and sends it back. And that's all it has to do. That's all the user code, that's all the developer code needs to do in order to make this happen. On the right, we've got the inserts required to register this. Now you can do all of this through the API control script. I prefer to go directly to the database, but it's literally exactly the same to go through the API control script. You just have to do it in a console. And then we start. Then at the bottom, you see me restarting the service. I don't know if you can actually see this, but I've put the hold_blame.pm in my home directory. And so I added that to the Perl 5 lib. And that's what allows the OpenSRF service or the OpenILS service to find the Perl module. So this is the plugin architecture is drop some Perl in a place where Perl can drop some Perl code in a place where Perl can find it, and then tell the database about that by regular Perl names, and it just works. So who failed my hold? Well, it was branch 2. It's always branch 2. So here, the background is the service processing the request. Here's the top of the result. I ran it through the JQ command. And then here's the bottom of the result. You can see that the circlib that failed was branch 2 at the beginning, also at the end. Now that's not particularly surprising because it's concerto and holds are only basically at one location. But you can see the 150 or so results that come back in. Now this 1.7 seconds that took was that also included all of the authentication dance to get an auth token and some other internal stuff that goes on in the test script. But the call itself only took, let's see, 0.8 seconds. And that was several hundred kilobytes of JSON blob coming back to us. Now, there are bugs. There's always bugs. I found a bug. Found a bug last night while I was working on these slides. So we're going to squash it. This was an issue with the IP-based rate limiting. I've already pushed the branch out for inclusion in 3.15.1. There was another thing that wasn't a bug but a performance improvement.
We do have a question.
Oh, do we? Awesome.
Yes, from Jeff. Cool. At 12:44, in the context of your hold blame packages, hold user versus editor user check. With an integrator account, will the editor user always be the integrator account, or do integrator accounts ever assume or impersonate a patron?
This was tested with a non-integrator user account. So I requested specifically when you authenticate with the service, if you do not say the login type you want, it uses the API login type by default. you can say, I want to log in using the OPAC or staff login types. You still have to have all the staff login permission or the OPAC login permission, whichever is required for the specific. Let's go back to that slide, I guess. For the specific login permissions are still required, but this was acting as this was actually acting as a regular user. So it would be me, my account, sending a username and password and saying log me in using the OPAC path, give me that auth token, and then I'll use that auth token to do my API requests. Now, can you impersonate a patron? There are APIs for that. I didn't go over the API surface in this one, but in the last in the Andrea and Ruth show, they mentioned there's different sets of endpoints available now. The hold, there's a patron set, endpoint set that lets you get hold and circ information for other patrons if you have the permissions to view other other users' information. So you can do it either as a third-party integrator. You can either take the user's username and password, log in as them, and act as them, or you can log in as your special API user account that has permission to, say, it has the view circulation or view hold permission, and at the appropriate org units, and can make requests to see other users' information if you would be allowed to do that in, say, the staff client, given a staff login capability. So it works in very much the same way as staff permissions, but it's restricted to the API path when you log in as an API user.
Yep.
Jeff, does that help?
And there's a follow-up from Bill as well in the chat.
Is failed? No, that is, this code is actually, this code right here, while it looks pretty similar to an Evergreen OpenSRF method, it's not. Instead of getting a we're getting short on time, I know.
I was to say you have 2 minutes.
This code is living inside of the OpenAPI server daemon, and that first parameter is a controller object that comes from the Mojolicious framework that is one of the lower layers of the overall OpenAPI Perl framework. But you are mapping, Bill, since you're asking about this, so we're mapping parameters, the EG auth token. I don't know if, yeah, you can see me moving my mouse around. So we got EG auth token, EG user ID, and param.holdID. Those are being, this parameter map here, the method params value on this table maps to the set of the EG auth token goes into SES, user ID goes, EG user ID goes into user ID, and param hold ID goes into hold ID. This magical first parameter is a controller object that lets you do advanced stuff like setting return or setting response HTTP response codes and things like that. So like I said, we did not get through it all, but I would be happy to take questions, comments, or comments. Ruth, I believe that it does. If it doesn't, I do have a how-to document that I know we've shared in the past, and I can make sure is linked on one of these slides.
Yeah, it's in the docs
as well. Okay, perfect.
and it is right here. Yeah, and I do want to echo Mike's comment to and other comments too. Please, like, look at these docs. It is extensively documented. So. Did you want to go back and show your code slides that you didn't get to?
No, the screenshots of code was what I was going to do. I didn't have any actual code on the screen, like actual text code. I just took some screenshots of my console. I'm getting old, Andrea. I can't be pasting and reformatting code into Google presentation slides anymore.
Would you like to share with the class what time you were working on these slides?
They were calling my boarding group at 2:37 last night. So I
By which
it
he
up.
means this morning. Time-honored tradition. Yep, and echoing Ruth's comment, KCLS, Equinox, ECDI, there was a lot of back and forth. There was a lot of discussion. There was a lot of, yeah, go for it.
Super big thanks to Jeff Davis from BC Co-op as well, because he pushed me to make some big serious improvements towards the end of the development cycle, and I think there will be a lot more to come with his input as well.
Yeah, absolutely. Yep. And if if you've got a favorite third-party service provider for Evergreen, encourage them to look at this stuff. So.
And we will be looking for those third parties to help us figure out what makes things in a reusable and hopefully relatively generic way more usable for them.
Okay. Any other questions, comments, etc. for Mike? All right. Thank you, Mike.
Thanks, everybody.
We will take a short break, and then coming up at 2 o'clock, my colleague Lena Hernandez will be talking about Aspen. That'll be at the top of the hour at, what did I say, 2 o'clock? I don't know what time it is. 1 o'clock Eastern, 12 o'clock Central, 10 o'clock Pacific. All right. Need to unshare so I can share my screen.